Azure Service Bus. We have earlier seen that we can have a WCF web role hosted as a cloud service for providing functionality to various clients on internet. Cloud service is going to execute in Windows Azure, and these clients, which can be mobile application, console application, browser based application through JavaScript or various other types of clients, can communicate with that WCF service. All this is fine as long as the service can be hosted in the cloud, that is Azure. But what if the service has to be hosted in on-premise environment? I don't want the implementation of service to go on to Azure because it has to access some secure data. I want it to be hosted in on-premise. But once hosted in on-premise, the basic concern is how are these clients which are on internet going to communicate with this service in on-premise environment? Will my network open firewall for all these clients? If that has to be done, we are introducing a big security hole in our network. Then what is the alternative? Yes, that is the kind of situation where Azure Service Bus is going to provide us a solution. So whether an application or service bus runs in cloud or on premise, it often needs to interact with other applications and services. Yes, every application actually will have some kind of interaction surely with other applications on the network within Azure, without outside Azure. So for this particular broad communication between discrete applications, disparate systems, we would use the secure infrastructure provided by Azure, and that is what is Service Bus. So Service Bus is going to allow communication between on-premise solutions to the Windows Azure solution. That means I can have some application running in Windows Azure and that can communicate with a service which is running in on-premise. And not only that, even a Windows Azure solution to other solutions within the cloud can also be done through Service Bus. So Service Bus is actually going to be in between two applications and will provide a handshake for the two applications to communicate with each other. So yes, sir, it provides connectivity options for WCF, which includes REST endpoints. WCF REST service, it would become very easily. So WCF actually supports two types of messaging capabilities. One is referred as relayed messaging and the other is brokered messaging. Now what is the difference? In relayed messaging, both the client and server, or otherwise you call it a sender and receiver, have to be online at the same time. Both should be running at the same time. And both can be behind the firewalls. So relayed messaging helps disparate applications and services to communicate through firewall, NAT gateways and other network boundaries. So it is a direct support to one-way messaging, request response messaging and peer-to-peer messaging. Now what is one-way messaging? We submit a request and we forget about it. We don't wait for the response. That is one-way messaging. Request response messaging is we submit a request and we wait for the response, and only when we get the response we continue further. Peer-to-peer is one-on-one direct communication. So this is all possible through relayed messaging supported by Service Bus. Likewise, we also have brokered messaging where asynchronous communication is going to happen between the sender and the receiver. That means both do not have to be online at the same time. Yeah, we would have something like a queue or topic. There is something called queue and topic which we are going to cover later, where Service Bus is going to be a broker. Sender is going to host the messages in the queue or topic, and there will be a receiver application. Also, we can also call it as a subscriber in context of topic, which is going to receive those messages and process them. Of course, the sender and the receiver need not be online at the same instance of time. So that is what is brokered messaging. So these kind of pattern are supported by Azure Service Bus. Azure Service Bus is a multi-tenant cloud service. What does it mean? Same service can be used by multiple users by creating different namespaces. See, what we actually do is we create a namespace for each client, and that namespace is going to have some security token. And pretty obviously, we are not going to share that security token with other clients. So all the applications of a given client would use one common namespace, and all the other applications of a different client can use a different namespace. So we will have a common service which is going to be used by multiple clients by just creating different namespaces. And that is why we say it is a multi-tenant cloud service. And of course, within the namespace is what we are going to create relays, queues, and topics. Now, what is the difference between all three? Relay is supposed to be bidirectional. Unlike queues and topics, it is bidirectional. Relays don't store in-flight messages. It is not brokered. They just take the message and simply forward it to the destination application. That means both the sender and receiver should be online at the same time. There is no offline communication here. Whereas queues and relay topics both are going to work with offline communication where sender and receiver need not be online. Then what is the difference? Queues are again one directional communication where a message once sent to queue can be retrieved by only one receiver. At any point of time, we can have only one receiver who can receive a message from the queue. So even if you have multiple instances of the receiver running, only one instance will be able to pick up a message from the queue. Whereas in topics, we will have the subscription model where we will have subscribers for a given topic. So if a message is posted in a topic, all the subscribers for that topic would get that message. That means there can be multiple receiver of the same message. That's what is topic. So yes, namespace serves as a logical grouping of all these instances. So when you create a queue, topic or relay, you give it a name. Of course, that name is supposed to be unique in combination with a namespace. That is a unique identifier for an object. So applications provide this service bus and then use that queue, topic or relay to communicate with one another. So this is how you see we have one namespace in which I have two queues and one topic. I have a namespace 2 which has only one relay. I have a namespace 3 which can have two topics and one relay. So you can have any combination. There is no fixed necessary that there should be only these many topics or these many queues in a given namespace. It is only to provide a unique name to the queue or relay or topic along with namespace so that it can be uniquely identified in a service bus. So what is that we need? We will need to have this WCF communication, queues, topics and event hubs. Windows applications can also use service bus defined messaging API. All this I'm going to demonstrate of course with an example. To make these objects easier to communicate from non-Windows application, there is support for Java SDK, Node.js SDK and other languages. And most beautiful thing, you also have support for REST API. If you remember, we have used REST API in storage account. Something similar here also we have support for. So with this, now that we understand what is a service bus, subsequently I am going to demonstrate with examples how relays, queues and topics can be used for communication between the two applications. Thank you.